Great. So David Mendez from the University of Michigan, welcome. I'm hoping you could comment on the overarching assessment of the utility of systems modeling. So do these methods work? Do they make a difference? And what metrics are used to evaluate them?
Thank you. This is a very interesting question. To me, these techniques have been available for many decades now, so they are still being used. So if they were not useful, we would have abandoned them many years ago. So they are useful, but the usefulness, I think, it depends on the expectations you have about them. Models are useful if they help you solve a specific problem or answer a question, something that you have in mind. And so, as Joel Gittleson mentioned before, there are different levels of complexity that you can put in a model to answer a specific question. So you just it's a mental, it's a representation, and a model is just a representation of an idea, hypothesis that you have about the process that govern what you are studying, and that you want to make it explicit for different reasons, and then that's how you evaluate how useful they are. If you want to be aware of your environment, a mental map, that shows you all the intertwined aspect of your system, is essential just to understand the complexity that you are living in. This is being aware of the environment. But if you have a more focused problem, then a more constrained part of that big mental map that focus on the specific problem, which is probably what you want to use and evaluate. So, for example, in policy, in tobacco policy in particular, that's where I work. I work in. So, our biggest problem is to evaluate the impact of policies, given that it takes a long time for them to be realized, right? So something that we can do now in tobacco policy, we're going to have, it's going to have repercussions or in 50 years, 25 years. So it's a very long time. So how can we just even think about the potential impact of the policies if we don't build these models that can help us, evaluate in what range our policies are going to be successful. And then for that, we have a specific questions. What would be the overall, mortality, caused by smoking or whatever it is in so many years. And so nobody can predict that. It's not for forecasting, but so have an idea of the magnitude of the problem, and then to have also derive a set of policies that are robust, I think Jack mentioned in his introduction. So no matter what you do, those policies are likely to, under a very wide range of circumstances that can happen in the future, they are going to be effective, and you are not going to be surprised by unintended consequences. That doesn't mean that things can change in the future, but that will help you make policy decisions now. Use the best information to make policy decisions now. So, of course, if you want to, for example, state or look at the best state of knowledge, one I think important aspect that models can do is it's in the realm of comparative models. So we have different teams, for example, developing a model about the same thing, and see and figure out where they differ, If they are, predicting, not predicting, but getting the same results on the ballpark, we're more confident about what's going to happen. If not, then we can actually see what the gaps in our current knowledge is. So if they are helpful for answer the question or the problem that you have, that's how we evaluate them.
Great, thank you. And I appreciate you emphasizing, some of these things won't be realized for a long time, but it doesn't mean we shouldn't do them or we shouldn't continue to work on them. It's kind of what we deal with in public health. Thanks, Nico.